r sine theta equals 5, and divide both sides by what? And that will give you r equals 5 what? Thank you. Alright, now let's look at the next learning target. It says go from polar to rectangular. R equals 5. Do I need to multiply both sides by r or square both sides?
Square both sides.
So r squared equals 25, and then you replace r squared with what?
X squared plus y squared.
Okay, if you had this right here, all you have to do is what? Y equals 7. Very good. What if you had r equals 5 cosecant theta? How could you first start off by writing r equals 5 over what? And then couldn't you cross multiply? And then r sine theta is equal to what? Are we good on those? Okay. Alright, next. Graphing polar equations. Your homework on that first page, we did 33 together, didn't we? Okay, let's look at 34. What type of problem is number 34 going to give you? What is that? A rose. How many petals would that have? 4. And where would the petals extend to? What ring? 3. Very good. Now, since this is an even, will it be 1 or 2 equations? 2. Okay. So I'm going to write this here so I can show you some room. R equals 3 sine 2 theta. There's the problem. We're going to look at just this part right here. We're not worried about the 3. We just know that's the ring you're going to go out to. So since this is even, I'm going to set up 2 equations. Okay. Ignore the 2. You got to think, okay, what trig function gives you a sine value of 1? What does that? Pi over what? 2. So now I'm going to say 2 theta equals pi over 2. That's what I did so far. What sine gives you 1 pi over 2? Plus what? 2 pi m. You always do that. Now I got to get theta by itself, so I'm going to divide everything by what? Theta equals pi over, that's going to give me pi over what? What happens to these 2's right here? Okay. Now, there's 4 petals. I got 2 equations. How many petals are going to come from each equation? 2. So that means for n, I'm going to plug in what numbers? 0 and 1. So I say pi times 0 is what? 0 plus 1/4 would just be what? 1/4, which I would just write as pi over 4. Does that make sense, Mason? Now I'm going to plug in 1. 1 times pi is 1 pi. Like 1 whole, isn't it? 1 whole plus 1/4 would be what? 5 fourths. Because 1 whole is 4 fourths. 4 fourths plus 1/4 is 5 fourths. Do y'all see that? Okay, now go to the other equation. What sine value gives me a value of negative 1? 3 pi over 2. Very good. Now I'm going to divide everything by what? When I say 3 pi over 2 divided by 2, that gives me what? These cancel out. Now I'm going to plug in 0. That goes away. I'm just left with 3/4. I plug in 1. 1 is 4 over 4. 4 over 4 and 3/4 gives me what? Okay, now I'm going to graph each of those petals out to ring 3. And that's my answer. Now yesterday we did we do 37, 38 yesterday? Okay, those are lambda what? Lambda-cents. Okay, remember cosine is always on the horizontal axis, sine is always going to be on the what? Pi over 4. You take the square root of what's in front of here. What's the square root of 1? So I'm going to go up to ring 1 on the pi over 4 and make an infinity sign. These are real easy. On number 38, you're going to take the square root of 2. I know that's not perfect. You're going to have to estimate. It's like 1.4. Okay. So I'm going to go to 1.4. Go past the little ring a little bit. And then make my infinity. Remember, on the previous two, cosines on that horizontal, okay? I took the square root of 25, which is 5, and went 5 that way, 5 that way. Y'all see the difference? Yes, well, yes, buddy.
So if it's sine, it's always going to be on the power 4.
Always on the power 4, yep. Always on the power 4. Are there any questions on that homework? Alright. Now, tomorrow your quiz is matching. You say, oh, Mr. Chester, what do you mean? I don't have to graph these by hand? No, I say that for the test. You have 8 of these to graph on your test. But this is what your quiz is like tomorrow. We're about to do a practice run to it. Alright. Guys, you really don't do much work on this because if you use your clues and let's just look at this. I got to zoom out for this because I need you to see the whole picture for just a second. Okay, we got a lot to do today. I like to go through my equations and pick out the ones I know quick and you can do easy. I'm going to start with the lambda sense, the one we just did. Those are the which ones? The R what? R squares, like number 3 and number 9. You see that? Now, on 3 and 9, now first of all, the graphs are weird. They're graphing them on the regular coordinate plane. That's which is crazy. So just bear with us. Now, on number 3, R squared equals 9 sine 2 theta. So you would take the square root of 9, which is 3, wouldn't it? It's always going to be on that power 4. Which one looks like that? M. It's either D or M, isn't it? So M is number 3. So let's mark that one out. So that means number 9 is which one? D. And mark. I want you to mark it out like that on your quiz tomorrow. No, this is not your quiz. It's very similar to this. Alright, which one you want to do next is easy? Circles. Okay, now let's talk about circles. Now, you say, Mr. Harris, there's a lot of circles. Didn't I tell you that sometimes the dimple, when you graph it, looks like a circle? So I want you to be very aware of that right now. Which ones for sure act like the circles that we graph? That's up there. B and F. I'm very glad you said it, because wouldn't B and F always at 0 at the pole? You see that one? This one, like G, that is a circle, but that's one of those dimple ones that you can barely see the dimple, okay? So do you see the difference between like G and B and F? B and F is at the pole. It's going to be at the pole if it's a circle, okay? So let's look at which one's a circle. 4 and which one? 4 and 13. Now, we don't have to work it out. B, is that a vertical or horizontal orientation? Vertical. Which one would deal with vertical? Sine or cosine? Sine. So number 4 will be what letter? B. So number 13 would be what? F. And do you see how 13 went out 4 that way? Okay. Alright. I see only one dimple at the pole. Which one's the only dimple at the pole? A. So number A, letter A will go with which one? 7, because that's the only cardioid you have down there. Alright. Now, let's do the ones that have the swirl. Which ones have the swirl? H and which one? N. H or N. So let's find the ones that have swirl equations. Which ones? 2 and 8. I'm looking at 2 and 8 right now. And guys, you don't have to work anything out. Number 2 has a cosine. Which one has a horizontal orientation? Yep. Number 8, which one has the vertical? N. There you go. You see how that's going quickly? Alright, now let's look at roses. We have 3 roses. We have number 10, number 6, and number 12. And number 1. Very good. Now, look at letter C. How many 8 petals do you have? Which one will that go with? That will go with 12. You're done with that one. J has how many petals? Which one will that go with? J. J has 4 petals. J should go with 10 because you remember you got to multiply the inner number. It's a 2, so it's going to have 4 petals. So that's why J goes with 10. C goes with 12 because 4 times 2 is 8. C has 8 petals. Do you see that? Now what you got to think about is K and L because we got 2 left. 1 and 6 are both 3 petals, so you're going to have to do some work on that. Okay? You have to do some work on that one. Alright, so let's look at number 1. I'm going to have to work number 1 out. Alright, so it says R equals 2 cosine 3 theta. Is that even or odd? Pay attention to this. Even or odd? So I'm going to have how many equations? 1. Now notice the petals has got to go out to what number? 2. Does that help us any? Well, they both kind of near 2. They both kind of, so you still need to work that out. So here we go. Cosine 3 theta equals 1. What cosine value gives me a value of 1? 0. I'm going to divide everything by what? I'm going to plug 0 in. 0 plus 0 is what? 0. So I'm going to have a petal at 0. Oh, can you kind of see which one that's going to be? Which one? Isn't K got a petal right up to the 0 where 0 degrees is at? Does that make sense? So your answer there would be, which one were we doing? This will be K. But let's finish it out just to make sure we know the petals. So that's 0. I plug 1 in. What's 2 pi over 3 times 1? Plus 0 is 2 pi over 3. So there needs to be a petal in the second quadrant. You see how that petal's in the second quadrant? I plug 2 in. 2 pi over 3 times 2 is 4 pi over 3, because that plus 0 is that. 4 pi over 3 is down here. That's why it matches up to K. This is kind of easier than doing it all, drawing it, isn't it? But don't worry, your drawing's on there on your test. So if this is K, what's the other one? L. So we down to the 3 that has a dimple but not at the pole. So here what I do, guys, is start plugging in values, your major points. What's sine of 0? What's sine of 0? 0. 0 times 2 is? 0 plus 5 is? So it's going to be going from 0 out to 5, isn't it? Let's see if we find one that's going from 0 out to 5. E. Do you see how it goes? It crosses at 5 over here. And there's that. Alright, number 11. I'm going to plug 0 in. What's cosine of 0? 0. 3 minus 0 is what? Oh, I'm sorry. Cosine of 0 is? 3 minus 2 is? 1. Which one goes out to 1? Ah, very good. And the last one has to be what? G. That's how you quiz set it tomorrow. Does that make sense? We're going to hold off on the checkpoint and do that another day, okay? Alright, yes. Yes, I'll be on that one. Alright, we hold the checkpoint off for another day. Alright, let's go over our homework from last night. Alright, let's do this quickly, guys. That took longer than what I planned. Okay, I plotted the points, so check your work. We would do the checkpoint with the quiz tomorrow. How about that? Alright, that'd be 2 separate grades. So it gives you another night to review roses, okay? Checkpoint's going to be a rose tomorrow. Alright, so there's the graph. Does anybody have trouble understanding how to graph the numbers in the complex plane? Like 5 plus 2i. Graph it like an x and y, but remember, this axis is real, this is imaginary. So 5 plus 2i be 5 up 2. Okay? 6. Remember, your first value is real, so I went to 6 and didn't move nowhere. 4i. Graph it as if it's 0, 4. 0 up 4. Are we good on that right there? Okay, good. Okay, let's check our modulus. What is modulus? It's the what? Absolute what? Value. Very good. Square root of a squared plus b squared. So number 5 is 4, number 6 is 3, 7 is 2, 8 is 6, 9 is square root of 29, 10 is square root of 58. 11 is 2, number 12 is square root of 1 1/3. Now, I want to see how many thought of this. I was thinking, okay, you can always take the square root of a numerator and denominator. I rewrote that as square root of 4 over 3. Does that mean the same thing? Can't you take the square root of 4? So I got 2 over square root of 3, and then rationalize. I'm not going to give you one like this. I don't know, I need to check before I say that. But do you see, you need to, if you get a mixed number like that, you need to think, okay, I'm going to rewrite that as improper, and then try to take the square root of the numerator and denominator. You talking about here? What? Just rewrite it as square root of 4 over square root of 3. So square root of 4 is 2 over. Does that make sense? Are there any questions on your homework? Yes. 10 is that supposed to be a 7?
Yeah, 7.
Okay, I got a z squared. Okay, 7 squared plus negative 3 squared, which is 49 plus 9. 58 is broken down to 2 times 29. You can't break that down any further. Now, I forgot last night in your homework to give you any of this. So this is what we learned yesterday, writing complex numbers in polar form. That's going to be your homework tonight, okay? Remember, when you do this, guys, I'm doing a quick review because we're going to go on. You got to find your modulus first. Put that on the outside of parentheses. Then you got to find your angle. Remember, always cosine comes first, plus I sine. Find your theta by saying this number divided by this, the coefficient, 1 divided by 1. Remember, you got to look up there and see what quadrant would that be graphed in. Then you got to pick the family member that comes out of that. For this was a tangent of 1. That's the power 4 family. Power 4, that's in quadrant 1, is power 4. That's how I came up with that. Y'all remember that from yesterday? Remember, that's going to be your homework tonight. We also did, and you're going to have this too, multiplying and dividing complex numbers. If you're multiplying, you multiply the outside numbers and do what with these? Add. If you're dividing, you say this by this and do what with these? Subtract, okay? That's your homework tonight, okay? Is everybody good? Okay, now, our learning target today is DeMoivre's theorem. Now, if you've taken French, he's a French mathematician. This is page 16. You might pronounce it a better way. But what does DeMoivre's theorem do? It helps you find the power of a complex number without having to multiply it all out. You know how the binomial theorem was like x plus 3 raised to the 16th power? And we could use Pascal's triangle to figure that out? Well, we don't have a Pascal's triangle for complex numbers. We have DeMoivre's theorem, okay? So this first one, guys, I worked one out for you because I just want you to look up here and look at me on this one. This first example is already worked out on your notes. So we want to find out what 1/2 plus 1/2 I raised to the 10th power is. Well, when you're given this, guys, the first thing you need to do is put it in polar form, like what we learned yesterday. We need to take this complex number and put it in polar form. So I found the modulus for this 1/2 plus 1/2 I. 1/2 squared plus 1/2 squared is 1/4 plus 1/4, which is, okay, 1 plus 1 is 2, 2 over 4. Take the square root of the numerator and denominator. Square root of 2, that's how I got that. What's square root of 4? 2. That's my modulus. I put that there. Now, tangent. 1/2 divided by 1/2. What's 1/2 divided by 1/2? 1. What quadrant would that be in if I graphed it? First. That's why I got power 4. So I wrote that just like I've been doing, like I learned yesterday. This is where DeMoivre's theorem comes into, okay? Whatever power you're raising this to, what's this one raised to here? The 10th power, okay? So once you do that, you got to go here and raise your modulus to the 10th power, whatever power is sitting here, and then multiply your angles by that number. So this is 1 power 4. You say I multiplied it by 10? Okay? Once I do this now, I have to do all this. Square root of 2 raised to 10th power is 2 to the 5th. You say, oh my God, how'd you get that? Okay. How's another way I can write square root of 2? 2 to the what? 1/2. So if 2 to the 1/2 is raised to the 10th, what's 10 times 1/2? That's how I got 2 to the 5th there. And then 2 to the 10th right there. When you do all that, you get 1 over 32. Because aren't these like bases right here? 5 minus 10 is -5. 1 over 2 to -5. Now this is a harder problem. We're about to do an easy one. I'm just trying to teach you the steps right now, okay? But even if you didn't do that, you could still say 2 to the 5th, then divide it by 2 to the 10th, and you're going to get that. But once you do all that, you got to evaluate this. Cosine of 5 pi over 2 is 0. Sine of 5 pi over 2 is I. So I got 0 plus I is I. I times that is 1 over 32. So this is just like a model for you. But we're about to take it slow, okay? So this is the one we're about to do. Okay, give me the one on the next page. What's the number 2?
2 plus 2 root 3 I.
Okay, 2 plus what?
2 root 3.
I to the what?
Raised to the 6.
Okay, here we go. Does everybody agree with that? So what's the first step we're going to do here? Write it in what form? Polar form. It's a good review from yesterday. We're going to write it in polar form. Find the modulus. 2 squared plus 2 root 3 squared. I want to make sure you agree with that. Is everybody good on how I got 4 on the modulus? Now, what quadrant would this be in if I graph that original complex number? 1, okay. Now, tangent of theta equals 2 root 3 over 2. What happens to those 2's? So I'm left with root 3. Which family gives me a tangent value of root 3? Pi over 3. And what quadrant is that in? First. Okay, so here we go. Let's write our polar form. So 4 cosine of what? So that's our first step, is just writing it in polar form. So that reviews what we did yesterday, didn't it? Now this is the neat part, okay? You see there's so much on this test, that's what I'm saying. You've got to start reviewing, okay? You take this number here, this 6. You're going to raise this 4 to 6. Now what you're going to take this 6 and do with these angles? Multiply, okay? So I have 4 to the 6. If I say 6 times pi over 3, that's going to be 6 pi over 3, isn't it? 4 over 6, is that 4,062? Oh, I was close. 4,096, okay. What is 6 pi divided by 3? 2 pi. 6 pi over 3 is 2 pi. Now, keep going. Do you know the cosine of 2 pi? What is it? What's sine of 2 pi? 0I. Now, distribute. What's 4,096 times 1? This times 0I would just be what? So what's your answer? That's it. So if you work that out, you multiply that out 6 times, that would give you an answer of 4,096. We've come a long way from algebra 2, haven't we?
Oh, yeah. There's a lot of straight.
They should call it trigonometry, not pre-cal.
And this is where pre-cal's not doing.
Oh, pre-AP pre-cal didn't do anything like this. This is where you go deeper. All right, let's look at one more. Nope, I'm gonna break it down. Number 3. What is 3? Last thing for the day.
Square root of 3 over 2 minus 1/2 I.
Hold on, I gotta see it. Alright, so what's the first thing I'm going to do? Put this in what? Polar form. Alright, let's find the modulus. Your homework tonight's only 2 of these because we're going to spend some more time on it. It's really what we did yesterday, okay? Alright, so I'm going to go square root of 3 over 2 squared plus negative 1/2 squared. Let's talk about how we're going to handle this because that might look ferocious to you. If I square that numerator, what will that give you? 3. If I square the 2, it gives you negative 1/2 squared is 1. But look how sweet it's about to work out. What's 3 plus 1? What's 4 over 4? What's square root of 1? There's your modulus. That just looks perfect, don't it? Alright, now let's find our tangent. Now we got to figure out, if I was to graph that, what quadrant would that be in? 4th, wouldn't it? You got a positive and a negative. Quadrant 4. Alright. Tangent theta equals negative 1/2. I'm going to write it like this because I'm going to have to end up flipping it. Because remember, it's y divided by x. And that ends up giving me this value right here. But you know you got to rationalize that, don't you? And you've done so much rationalizing now that you know it's going to come out to that right there. So you have to think, what tangent family, what family gives you a tangent value of root 3 over 3? Pi over 6. Which pi over 6 family is in quad 4? So that's how you're about to write this. So we're going to write this as, 1 cosine 11 pi over 6 plus I sine 11 pi over 6. My 1 got very happy there. So you're halfway through the problem. You've written it in polar form. That's why I do these. I like to practice polar form. So this gives you more practice polar form. Now we're going to apply DeMoivre's theorem. Negative 5. Alright, I'm going to raise the 1 to what? And then multiply these two things by what? So it'd be cosine of negative 55 pi over 6 plus I sine negative 55 pi over 6. Now first of all, we are all intelligent students. 1 raised to anything, it doesn't matter if it's positive or negative or what. 1. So we're just going to put a what outside? A 1. Okay, we're going to put a 1 here. Now this might be bothering you in a minute, so let's come over and talk about this a minute. Just change it to a mixed number, because you've got to evaluate that. How many times 6 go into 55? How many times? 9 times with 1 left over, isn't it? So let's figure out what quadrants that's in. Okay, we're going backwards. Boom, 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 boom. It's odd. So we know we're right here, back here. If we're going this way, we're back here. I need 1/6 more. Would it be quad 2 or quad 1? Okay, hold on. It's in quad 2, but let's look at mine. Normally I go this way, don't I? But since it's negative, you're going this way. So 8 pi would be right here, wouldn't it? 9 pi is right here. I need 1/6 more. Quad 2 or quad 1? Do y'all see that? Okay, quad 2. So I want the cosine of that. What would that be? Positive or negative root 3 over 2? Negative root 3 over 2. What would this be? Positive 1/2. Distribute the 1. And that's your answer. All this is Friday. That's what I'm telling you. It's imperative. You start now. 35 questions on Friday. I'm even going to allow you to come in 0 period and start it early, so you can finish it. This is not the hard lesson is hard. This is still the easy stuff. So you need to go home tonight and watch any video or anything, but this is not the hard thing that's on the test. But if you learn, hey guys, it's really